All right, so warm-up number 75 shouldn't take you long. It says make a table with all possible outcomes. What kind of probability is this? So I'll give you some time for that. Go. All right, show your neighbor what you did. See if they agree with you in regards to the probability presented. What probability was that? Let's see. How about all right, have a good day. How about Mia Victoria? What kind of probability is that? Classical. Hands if you agree with that. That is correct because we didn't do anything, any experience on it. We just took the data and used the theory in order to come up with a table. Is that correct?
Yes, Mr. Q.
All right, good. So with that said, copy the agenda, please. Warm-up number 75. Today we're going to wrap up this 4-1, which is a smooth transition to probability. And we're going to be working on applying concepts numbers 1 through 7 for tonight. However, you did have home play 15 through 18, and then the other day we had 1 through 14. So go to Canvas, turn that in, please. And then get a Cornell note going. All right, also copy this code, SZLEM, SZLEM. That's going to give you access to the home plate for tonight. Especially those of you that are following along on YouTube. Copy that. That's for your Nearpod code. All right. So once again, last night's home play was 15 through 18. The previous night's was 1 through 14. Make sure you turn that in. It's only 4, that's 800 points only. So there you go. All right, here we go. I can identify and compute basic probability. So we're still in the middle of this. Remind your neighbor the definition for probability, please. All right, good. All right. And you're setting up your Cornell notes. I'll wait for you. Anywho, with that said, so probability, the chance of what? Very good. An event occurring. And we're talking about classical, empirical. Today we're moving on to the last one, subjective. Okay? So we talked about classical and empirical. We have those formulas. And we did an exercise using both of these to know the difference between one and the other. So once again, share with your neighbor the difference between classical and empirical. Share with your neighbor the difference between classical and empirical. So you're like, Mr. Q, just give us a pop party. Let's go. Oh, okay. All right, let's see. Who haven't I picked? Jaden. Difference between classical and empirical. Wait a minute. Didn't you say that yesterday? Oh, okay. Yeah, he's the one that gave us this. It's a default setting, and in a sense, we can do this without experiencing it, or in other words, we can do that in theory, if you want to think about it. And this one we have to experience. Is that correct? Experience. However, this deals with real numbers. Is that correct? From the die. This one also deals with real numbers from the rows that we give. But all of them, we said that they add up to what? 1. Now, One more observation, look up to the screen. Who notices that the outcomes for the classical all have an equal amount of probability? Is that correct? However, empirical, are these equal? Not really. Some are off a little bit more than the others. Okay? They're getting close, but not quite. Okay? So with that said, we're moving on to subjective. So on your paper, write classical on the left, empirical in the center, and subjective on the right. Classical, empirical, subjective. So for classical, we said it's a default probability, or in other words, just using theory from whichever event, from events. So if you are given a die, so you're taking all the outcomes that you see on that die, and that's how we get that. Empirical, what would be a word that we use for empirical, everyone? What is it? What is it? I'm sorry? Experience. Experience. And also for classical, it's going to equal to 1, all probabilities, right? Empirical, it's going to equal to 1, all probabilities. And for classical, is basically all equal chances. For each event, all have the equal chance. However, experience, not quite equal, because it was off just a tad bit. So right now we're going to experience subjective, okay? Now for subjective, I'm going to show you a video, and you're going to take data from that video. For those of you watching on YouTube, I'm going to pause the video right now, and then I'll come back with the instructions. So, you just watched a video, and for those of you following on YouTube, you can find this video on YouTube. It's Jeremy Lin, New York Knicks against the Lakers back in the Insanity days. Look for the highlights. And we observed Jeremy Lin doing stuff on the court. So I want you to answer 2 questions. What is the probability of Jeremy Lin making a basket? And what is the probability of Jeremy Lin making a pass? So we're just looking at 2 things, basket or pass. Don't talk it over with your neighbor. I want you to write your own data. Do that right now. Go. All right. Answer on the screen. What would be your probability that Jeremy Lin will be shooting the ball or passing the ball? This is personal stuff. Don't share with your neighbor. Good thing you were very observant. Yes? All right, good. Here go some of your responses. Look up to the screen. The probability of shooting the ball is empirical. Oh, very nice. I was looking for numbers. Bah. Here goes the next one. 60 for shooting, 40% for passing. Okay. 50-50. 18 points, I have not missed a shot. Did 3-pointers, 9 out of 9, and 3 out of 3 passes. So 9 out of 9, 3 out of 3 passes. Okay. 60-40. 50-50, 42-58, half and half, 70-30, 50-50, 43-60, 43-60. Okay. Tell your neighbor what's up. Okay. 50-50, and so on and so forth. Oh, here's another one. 70. Oh, okay. Oh. Anyways, so think about it. What do you guys notice from all the different responses? Think about it. What do you guys notice? And then Peyton's going to answer the question. What do you guys notice of all these numbers? Talk it with your neighbor. What do you guys notice of all these numbers? All right, what do we notice, Peyton? They did not all add up generally, okay. All right, but what I'm saying is that what do you guys notice about this data? Just high. More likely to shoot, okay. Yeah, but did we get an exact number for everyone? Okay, so guess what? What you just experienced is what we call subjective probability. What would you think would be a definition of what we just experienced? What would be a definition? Subjective probability is what? Talk about your neighbor. What would be subjective probability? First of all, was it accurate? No, so let's write here, not accurate. What else did you guys notice? What is it? Personal point of view. That's why we hardly ever use subjective probability, because it depends on what people look at and how they look at whatever the events. And notice, all of us looked at it a little bit different, right? So, and in that game, there are actual numbers that you can record in that game and gives you specific data. And now that I asked you in regards to shooting and passing, you can go back, watch the video, and come up with an actual number. But that's basically it. Subjective probability is not accurate, and it's more in the personal point of view. All right? So, any questions between classical, empirical, and subjective? No? All right. So, on your paper, again, write empirical on the right. So move a little bit further down on your paper. Classical on the left, empirical on the right. So, this is what we're going to do. You're going to get in teams of 2 again. Each of you are going to get 1 die, so it can go a little bit faster. So for the empirical, outcome, and right here, frequency, 1, 2, 3, 4, 5, 6. All right? So, at this time, get into teams of 2. Send a gopher to go get 2 dice over there on my desk, and I'll give you further instructions. Go. So, you're going to take your die, and this time I'm going to give you the N. Tell your neighbor what this means. What does this mean? What does that mean, Fernando? I'm sorry? The total number, that means how many total rolls, everyone? 9. So, I want you to roll 9 times and record it on your table. The frequency, only 9 rolls. Go. Yes. Yes. You have your own dice, right? Your own dice. All right, we got it? So, let's see, let me record some data. Help me out, Lenny. What was your data here? For 1, 2, okay. So, you have your own data, yes? All right. So this is what we're going to do next. Make another table. And this time, here goes. N is, let's see, give me a number, Diego. All right, 40. That's a good number though, but we're going with 40. You're like, what? Yes. So tell your neighbor what this means for this table. Yeah, so you have your die, go. Start recording data. Okay, once you're done with your 40 rows, I want you to add up each row to see what you got. Each row, add them up. All right. So let's see, I'm going to go with, let's see, Diego, are you done? All right, give me some numbers. 6, 5, uh-huh, uh-huh. You got what? 3? All right. How about your numbers, Fernando? Okay. So, check this out, guys. I want you to do this. This is Diego's data. This is Fernando's data. I want you to copy the 2 on the side of yours. So like that, you're going to have 3 datas: Diego's, Fernando's, and yours. So write them next to yours. All right. So let me move this up out of the way. So for the first set, we did 9 rows. For the second set, we did 40 rows, okay? So now we have Diego, Fernando, and yours. So the total rows that we're looking at now is what? N is what? 120. Is that correct? Yes. That again? No, no, go ahead. Okay. All right, so we should have how many total rows on your data right now? 120. Okay, so I'm going to use one more set of data just to go with this. How about, let's see, Chelsea? Yeah. 11, 18. Can't hear. 15, 13. What is it? 18, 22, and what? 18? 8. This was your data? No. Oh my goodness. All right, let's try this again. C for Chelsea. She's going to give us her data. 11. Okay, let's try this again. Here we go. All right. So Chelsea's going to look at her first roll, 6. What is it? All right. So this is what I want you to do, guys. I want you to add all data for each row. So for these 3, that's 12 plus 5, that's 17. For these 3, that's 29. For these 3, that's 16, that's 21. Yeah, your own and then those 2. For these 3, that's 14. For these 3, that's 25. And for these 3, that's 14. Yes. Yeah. No, not the 3. So for example, Chelsea's going to add this one plus Diego's and Fernando's, so that's 3 datas, and that's the total. So for Jair, you're going to do Diego, Fernando, and Jair. Yeah? All right. So let's wrap this up. Look up to the screen. When we got to classical, outcomes, probability, we have 1, 6, 1, 6, 1, 6, 1, 6, and 1, 6. So far so good, yes? All right. And what did we say? That it all adds to 1. However, all of these are equal probability, yes? For each one of those events. Oh, I'm missing 6. 1, 6. They're all equal. However, if I was to ask you for your data here, some of you, check this out. Let me erase this. Who's missing on your first 9 rows? Which one did not have any data? Who had one that did not have any data? A lot of us, right? Jaden, so give me your numbers on the first roll of 9. No. On the very first one that we did. Okay, you said what? 6 for number 1. 1, 2, 3, 4, 5, 6. 2 for this one. And that's it. What do you guys notice? When Jaden rolled, he didn't even roll a 4, a 5, or a 6. Are those equal chances for each of these? No, right? However, that was only with 9 rows. When we increased the rows, what do you guys notice here? We at least have some data on those numbers, right? And then when we add some more numbers and more numbers, look now, these numbers right here, look up, observe these. Are they pretty close? Some of them, right? The ones that are a little bit off are this one, and this one, but pretty much they're close. So what can we conclude if I was to ask you to continue rolling, maybe roll n being 1,000? What do you think is going to happen to all these numbers as we continue rolling? Talk it over with your neighbor. What do you think is going to happen with all those numbers? Yeah, what do you think's gonna happen, Caleb? If we continue rolling to 1,000 rolls. That is true, more results, yes. But what kind of results? David, what do you think? Similar for all of these, they're gonna start doing what? Evening out, right? Or basically almost mirroring classical probability. So the more rolls, the more we get closer to a what? An equal probability. That's what we call, write this down, law of large numbers. Law of large numbers. Law of large numbers. So what does that law say? Well, if we do an experiment empirically, that the more we experience, the more each of these outcomes end up evening out or end up closer to what? Equal. All right, I'm going to stop right there. I'm going to leave on your screen, on my screen, there's a home play right there for those of you following at home. And those of you that got the code earlier, make sure you have that because you're going to need it. And enjoy your home play. Bye.